This talk in the Building Minds with Patterns series is about the coordination of an artificial mind with its reality. This is the second talk in a three-part series covering the genesis of an artificial mind, the process of observation, the coordination of a mind with its realities, and the development of an artificial mind from infancy through adolescence. Before we begin, please click the like button and subscribe to the channel. Also select the notifications to be made aware of new videos in this series. This is a generic cognitive architecture. In essence, a cognitive architecture is a blueprint for an artificial mind. Here we see areas for observation, coordination, reflection, and consolidation, as well as the device situated in a real or virtual world. Just as our own bodies are interfaces to our reality, the device is an interface to the reality of the artificial mind. This device communicates with the artificial mind through observation components, which store input from the device into the memory. The observation components are also responsible for communicating with the device's actuators, which perform actions in the world. We also see there are coordination components which update the memory with new inferences. The reflection components are responsible for changing the overall behavior of the system. And finally, the consolidation components are responsible for ensuring that the memory does not exceed its available capacity. The coordination pattern creates inferences to augment sensory observation. This covers a range of processes, including proposition activation, belief propagation, proposition association, concept induction or chunking, action synthesis or solving, and operation synthesis or reasoning. The inferences created in this process are called coordinations. In Jean Piaget's vernacular, there are observables, which are sensations, and coordinations, which are inferences. Assimilation and accommodation are Piaget's fundamental processes. Assimilation is the formation of new schemes that incorporate observables and coordinations via association, reasoning, and problem solving. Since they form new schemes, the assimilation mechanisms include the associators, the solvers, and reasoners. Accommodation is the modification of existing schemes by association, chunking, and negation. Since they modify existing schemes or belief parameters, the accommodation mechanisms include activators, propagators, and chunkers. The coordination pattern involves all of these mechanisms interacting with a shared memory, called the totality. Don't think of an elephant. George Lakoff. Activating. The activator mechanisms are responsible for transferring activation among propositions contained in the knowledge base of the artificial mind. In biological systems, certain cells called excitatory cells or telegraph cells have the capacity to generate and transfer electrical impulses amongst themselves. This is known as spiking or firing. In artificial neural networks, this phenomenon is mimicked by the assignment of weights to nodes, also known as units. In general, artificial neural networks have activation functions that update synaptic connections among nodes across layers in the network. When a connection exceeds a pre-designated threshold of activation, nodes with connections above the threshold are considered activated, while those below this threshold are considered inactive. Activated nodes on a particular level of the network contribute to the activation of nodes in subsequent layers of the network. In semantic networks, a process called spreading activation makes certain nodes in the network relevant when contextual cue concepts are presented to the network in order to imitate the priming effect found in cognitive psychology. That is, when people recall information quickly once related cueing concepts are presented to them. In all cases, each cell or node is presented with a stimulus, and other cells or nodes are affected in certain biological or synthetic ways. Activation is said to transfer from one cell or unit to another. The notion of activation in the totality is quite similar. For propositions contained in the knowledge base of an artificial mind, activation time is transferred among propositions based on several factors. The totality is the shared memory of the artificial mind. The memory units can be envisioned as residing within a sparse, multidimensional, dynamic Euclidean matrix. The matrix itself is dynamic since it begins with a single memory unit and expands or contracts along each axis as units are added or removed. Each z-axis unit is called a tier. Each x-axis unit is called a column. Each y-axis unit is called a row. And in addition to these axes, there are several additional dimensions which are not captured spatially. Realities are dimensions along which activation can travel. Realities partition the matrix with respect to activation. Viewpoints partition the matrix in terms of coherence and consistency. Viewpoints are reasoning contexts or microtheories, which may be locally coherent and consistent despite being globally incoherent or inconsistent. The elements of the totality are activated using time. Each memory element is timestamped to indicate the element is active, and then as time progresses, the element decays until the time exceeds a certain interval called the activation window, after which the element is no longer considered active. The memory unit is called a neural proposition or scheme. A scheme is a unit of memory in the totality. It is a neural proposition and is comparable to a neuron. It has afferent dendritic inputs called arguments, efferent dendritic outputs called referents, and an axonal unit called the reifier. It also has a relationship in its body, or soma. The relationship determines how activation flows through the scheme. The reifier is a scheme identifier. The relation is the reifier of the relationship. Arguments list the input reifiers to the relation, and referents list the output reifiers of the relation. For each argument and referent, there are also structures that join them to the scheme. The argument and referent structures are joins called brushes. They join each argument in the scheme's argument list to another scheme, and join each reifier in the scheme's reifier list to another scheme. Since they don't have an axonal reifier of their own, they only have terms. The brushes serve as connections or joins to other schemes, much in the same way join tables function in database parlance. To hold the schemes in position within the totality, there is glue, but not just any kind of glue, the translucent, slippable kind you find on Post-it stickers. Adjustable glue, glue that can be repositioned. The coordinates position the glue within the totality. The glue can be envisioned as a coordinate or point, which the scheme connects via the reifier. The referents are typically above the scheme on higher tiers. The arguments are typically below the scheme on lower tiers. Each reifier, whether argument or referent, is eventually glued into the totality. From the perspective of glue, each reifier is a distinction that occupies a specific Euclidean coordinate within the totality. This can be called a glial view of the totality. Some reifiers have labels, and all reifiers have a usage count. The usage count is necessary for the process of forgetting. A schema is a subsystem of connected schemes, whereby the arguments of a scheme become the relations of the subordinate schemes. The assimilator creates schemes, the lexer labels schemes, and the accommodator copies schemes. The make request creates a new scheme and returns its reifier. The join request creates a brush, which is an association among reifiers. The lexify request attaches a label to a scheme. If a reifier is not provided in the request, lexify will return the associated reifier for the label, and if none exists, it will request a new scheme for the reifier from the assimilator. The label request retrieves the label of a reifier. The copy request duplicates a scheme with edits. Schemes reside within a sparse, multidimensional, dynamic Euclidean matrix. Schemes form an ontology. An ontology is a morass of hierarchical relationships. The ontological view of the totality shows relationships within schemes and connections among schemes. It is envisioned that billions of schemes will reside in the totality. The schemes should tend to cluster in various regions based on predefined relationships that bootstrap the cognitive system. New relationships will necessarily be created from the predefined relationships. The perceptual region forms the bottom tier of the ontology. Features are activated by percepts, and they form the next tiers. Entities are assemblies of cross-modal features. They are activated together in unison. Structures, such as ideas, classes, and concepts, form the conceptual region of the ontology. The event region combines language with actions. The episodic region combines events over time. The behavioral region unites action selection and problem solving. The operational region connects logic and reasoning. A reality is a dimension for propagating activation. In the artificial mind, there are several realities: observed sensory experience, desired future reality, expected future reality, possible situations arising from hypothetical reasoning or self-directed problem solving, attained expectations, confirmed expectations, undirected imagination or mental simulation, and recalled sensory experience. Each reality partitions the memory into areas of independent activation, allowing the synapses to be concurrently activated for different purposes. I am that. Sri Nisargadatta Maharaj. Maharaj meant that the only true statement that can be said of a person is that they are aware, and by implication, they are awareness. A viewpoint is a reifier which indicates a context for activation and reasoning. The first viewpoint is awareness. Other viewpoints are created and adopted over time. Initially, the totality is empty, and the only viewpoint is that of general awareness. Then the mind begins to make distinctions in the world, and more distinctions. Eventually, the mind discovers the self as an entity also in the world, separate from others. The mind adopts the viewpoint of the self and becomes self-centered. Then the mind begins to recognize that others in the world have their own viewpoints, and so begins the adoption of theory of mind, recognizing situations from the viewpoints of others. The notion of the self becomes evolved, and the mind promotes the positive characteristics of the self, adopting the viewpoint that Jung would call the ego. Rarely, a mind comes to understand the negative characteristics that it holds, and can view itself and others from the perspective of the shadow. Awareness is the initial viewpoint. The self is the view from self-awareness and self-interest. You have other perspectives created as needed. The ego is the view from consciousness, preferences, and responsibility. The shadow is the view from ignorance, aversions, and freedom. What is a moment? A moment is a 16-digit number representing a nanoyear. It's approximately 3/100ths of a second. Some examples are as follows. The underlying language has a function that creates moments. If no parameters are given, it returns the current time in moments. When activation is spread within a reality, it can flow in three ways. It can be dispersed upward from observables to coordinations, downward from desired coordinations to observables, or radially cascaded in all directions. When a scheme fires, it spreads activation within the totality. To do so, a scheme first coalesces activation from its arguments to its reifier. Then it disperses the activation to its reference according to one of several flows. This approach is based on what occurs in biological brains. Coalescing or merging activation involves determining the activation time and activation signals of a scheme based on its arguments. There are 8 ways to merge the activation time and signal of a scheme's arguments. 1 allowed, pass-through, not, and, sequence, or, nor, vote. The merge type of the scheme's relation determines how to coalesce activation. The merge types are 1. Only one activation is permitted, pass-through activation, not, complements the activation, and is all or nothing activation, sequence, sequential activation, or any activation will suffice, nor, no activations are allowed, and vote, a majority of activations is required. The merge connects the relation with a specific merge type. Some examples are the relation category uses an OR merge, the relation series uses a sequence merge, and the relation unison uses an AND merge. To disperse activation means to trigger updates by potentiating related schemes. Often these updates are based on a directional flow occurring within a specific viewpoint in reality. For example, the observed reality disperses activation upwards from observables to coordinates, that is, from observed arguments to scheme reifiers, then laterally from arguments to reference within the scheme. In contrast, the desired reality spreads activation downwards from desired objectives down to associated observables. That is, activation flows downward from a desired inference all the way down to a percept at the bottom of the totality, and within a scheme from reference to arguments. The recalled reality cascades and attenuates activation radially within a viewpoint in all directions from an activated scheme to its neighbors based on radial proximity within the totality and on the activation strength. This is an activation structure. It establishes a context for the activation using the viewpoint, reifier, and reality. It establishes when the activation was initiated, either for enablement or impediment. And it shows when the activation terminated, using the enabled until and impeded until fields. The pulses is a count of the activations received or inhibitions received. The merge is the flow or the merge type for the relation of the scheme. The activation also has its own identifier, and in addition it has an antipode, which is the identifier of the opposite of this activation. If the activation has an antipode, this indicates the reifier has a dyad, its negation. Therefore, when the reifier is enabled, then the dyad is impeded, and vice versa, for the specified reality and viewpoint. Initially, reifiers do not have dyads. Dyads and antipodes are introduced under special circumstances. The artificial mind also has a configuration, which is a registry of key values and description fields called memos. The activation window registry entry indicates how many moments a scheme should remain active. This is typically about 3 seconds. The immediate potentiation registry entry indicates how much time it takes to form unimodal assemblies. This is approximately 1 second. There are a number of activation mechanisms. The job of the activator is to enable or impede individual schemes upon request. When messages to enable or impede schemes are received, the activator updates the scheme in the totality. The activator may receive a request to enable a particular reifier, in this case 8943, at a particular moment. If no reality or viewpoint is specified in the request, defaults are used. An entry is made for the activation, and the pulses field is set to 1. Additionally, the enabled since and enabled until fields are set to the moment for the particular viewpoint reality and reifier. If additional activate requests come in for the same reifier, the number of pulses and enabled until field are updated. If a request to inhibit the reifier is received, the pulses is reset to -1, and the enabled and impeded fields are updated appropriately. Additional inhibition requests, when received, will update pulses and impeded fields appropriately. The job of Chronos is to use the configured activation window to expire activations by resetting the pulses field to 0. If no other signals or requests are received for the 8943 reifier, then eventually it'll expire and the pulses will be reset to 0 by Chronos. The job of the observer is to spread activation across tiers in a bottom-up fashion, from arguments to schemes, and from schemes to reference in the observed reality. The job of the anticipator is to spread activation across tiers in a top-down manner, from reference to schemes and from schemes to arguments in the expected reality. The job of the reminder is to spread activation in a radial manner across tiers, columns, and rows in the recalled reality. The job of the dreamer is to spread activation across tiers in a bottom-up fashion, from arguments to schemes and schemes to reference in the imagined reality. Propagating. While activators modify the activation of schemes, propagators modify the statistical belief parameters, such as certainty, desirability, likelihood, reliability, and so forth, for each scheme. This allows agents utilizing the proposition to leverage quantitative statistics about each proposition of interest to make informed decisions. Belief propagation, therefore, is the means by which the statistical information about relevant propositions is updated. This is a continual process, since propositions, which are schemes, are continually created, modified, and forgotten. A belief structure is shown. The viewpoint and reality establish the context for the belief. Emotion in the cognitive system is based on a simple notion of valence, the measure of good or bad, positive or negative feeling, and arousal, the measure of excitement or indifference. This emotion can be ascribed both to the sentiment of the artificial mind as well as to individual schemes. Certainty is the degree of confidence that the reifier is true, and coherence identifies the degree to which the reifier fits in with others in the context. Likelihood is the probability of future activation, and actions most likely to activate this reifier are tracked. The belief has an identifier, and it also has a diametric, which is the identifier of the belief's dyad, if it exists. Actions. Action parameters have a reifier of the action, the number of attempts to use the action, and the number of successful attempts. This allows us to calculate a simple success ratio. Needs. Each need of the artificial mind is also tracked. The delta is the difference between the target value of the need and the actual value. There are several mechanisms that have to do with belief propagation. The gluer detects new schemes in the totality and creates glue for them. The arranger continually rearranges the matrix by updating glue coordinates in order to drift scheme arguments towards scheme reifiers on the XY plane, maintain sufficient distance between schemes, keep reference above their scheme reifiers, and keep scheme reifiers above their arguments on the Z-plane, and settle schemes having no arguments, typically observables, toward the bottom of the totality. Arousal is based on the urgency of an objective. A scheme becomes aroused if it becomes an objective or desideratum, or if it is activated in the desired reality. For urgent schemes, this mechanism creates a belief, if the scheme lacks one, and updates the arousal value between -1 and +1. If the dyad exists, it also adds the negative arousal to its dyad. Desirability is based on the salience of an objective. Whenever the salience of an objective or desideratum is recalculated, the valence of the scheme is also recalculated. This mechanism creates a belief if the scheme lacks one, and adjusts the desirability value between -1 and +1 of the belief, and sets the negative of the desirability to the dyad. Coherence indicates how well a scheme fits in with related schemes. Coherence can be measured using a scale from -1 incoherent to +1 coherent. Disconnected schemes are given a 0 coherence value. Thagard characterizes the coherence task as dividing a set of propositions into accepted and rejected collections in a way that satisfies the most constraints among them. In this case, constraints are either positive, a relation exists between the schemes causing them to be compatible, or negative, a relation exists between the schemes causing them to be incompatible. Positive constraints include relations of entailment, meronomy, association, similarity, and purpose. Negative constraints include relations of inconsistency, negative association, dissimilarity, incompatible action, or incompatible belief. Thagard also suggests that positive constraints are satisfied by accepting or rejecting both schemes. Negative constraints are satisfied by accepting one scheme while rejecting the other. In general, coherence problems are NP-hard. Since a global partitioning of all schemes into accepted and rejected sets is not required, a pragmatic and suboptimal yet psychologically plausible approach is taken here that does not attempt to maximize global coherence, but instead focuses on local coherence. The coherence propagator mechanism determines how well a new scheme coheres with existing schemes in the totality using an incremental local coherence strategy. Coherence for a new scheme is updated by sorting the scheme's arguments and reference into accepted and rejected lists. A coherence score is then computed using the lengths of the accepted and rejected lists. Thagard has pointed out that the incremental approach is subject to ordering bias, leading to accepting schemes that would normally be rejected and vice versa, based on the order in which schemes are processed. This is addressed by occasionally recalculating the coherence for schemes. The coherence value is used by the amniator mechanism to determine whether schemes can be forgotten. Non-coherent, having coherence values of 0, and less coherent, having lower values, schemes will be forgotten before more coherent schemes. For an objective, the likelihood of success is based on applicability and reliability of actions relevant to the objective, and is measured on a scale of -1 unlikely to +1 certain. The estimator mechanism finds the most relevant and applicable actions for an objective, and computes a simple likelihood score based on the reliability, successes divided by attempts, of the actions. To live is to suffer. To survive is to find meaning in the suffering. Friedrich Nietzsche. Associating. For the purposes of activation, schemas are circuits that control activation flow. The associator mechanism makes these circuits. Observables such as percepts and features form the base of the totality. Image schemas reflect spatial relationships among the observables. Simple relationships between two schemes are called horizontal relationships. Vertical relationships reflect groupings of multiple schemes. Gate relationships control the flow of activation from arguments to reifiers. And structures reflect complex associations. There are also several derivative circuits. Observables. The lowest level ontology contains observables. We have features, percepts, results, and urges. Features are synthesized constituents of things in the external world. These constituents are found through detectors. Percepts are received correlates of things extant in the external world. The perceiver agent receives percepts from the psyche, which is a software residing on the external device. Results are proprioceptive outcomes of attempted actions, and urges are interoceptive states of homeostatic variables or needs. Images are image schemas. Image schemas reflect spatial relationships among observables. Above, across, apart, behind, beside, boundary, contact, container, path, together are image schemas. The most fundamental associations are those of orientation and temporality. Orientation refers to whether the association is horizontal or vertical. According to Wickelgren, a horizontal association is one where complex ideas are represented by a strongly associated set of elementary ideas. In other words, a scheme. Genus, grounding, member, slot, swap, symbolism, and tandem are all horizontal or simple relationships. Genus is a taxonomic positioning of two elements, a mesa or a lower element and a meta or a higher element. Groundings are connections between associated triggers and a percept. Members are examples or instances of a genus. Tandems are an ordering of two elements, a prior element and a later element. Slots are bindings from a category to an element. Swaps are substitutions of an original element for a proxy element. And symbolisms are evocations by a present thing of an absent thing. A vertical association is a grouping where a complex idea is represented by strong locally hierarchical associations to and from constituent elementary ideas. Vertical associations include different, equivalent, identical, incompatible, and similar. Temporality refers to whether ideas are activated in unison or in series. Holland, Holyoake, Thagard, and Nisbet explored synchronic, which means in unison, and diachronic, which means in series, associations. They say mental models are best understood as assemblages of synchronic and diachronic rules organized into default hierarchies and clustered into categories. These circuits are gates. Categories are an unordered set of elements. Choices are an unordered, mutually exclusive set of elements. Leagues are a coalition activated by majority voting. Orderings are an ordered set of elements. Unisons are a concurrently activated assembly of elements. And series are a sequentially activated cascade of elements. Structures. Ideas, prototypes, classes, and concepts. Ideas are agglomerations of slots. Prototypes are agglomerations of categories, also called roles. Classes are hierarchic arrangements of ideas and classes. Concepts are classes and traits reflecting aspects of a reality. Ideas contain slots, and slots are category and element pairs, where each category is an attribute and each element is a value. At this point, it is an open question within John Piaget's genetic epistemology whether or not egocentric or intuitive stage children form preconceptual ontologies, as opposed to having an agglomeration of concrete categories. Note that categories are distinct from concepts. For example, is there any evidence that an egocentric or pre-operational child would consider a lion, a tiger, and a leopard as variants of the same abstract category, or would they lump them together as distinct entities in some mental basket? Lumped along with pictures of cats or cartoon cats or remembrances of Hello Kitty, or lumped in separate baskets, combining stimuli into percepts, the assumption made herein is that preconceptual idea hierarchies are initially created. Ideas arise from sensory experience or problem-solving activities. Whenever possible, ideas are grounded in perceptual stimuli. The grounding structure maps ideas to percepts. Prototypes. Prototype are lists of roles. Classes have a genus, which is the superordinate class, kinds, which is a list of subordinate classes, categories, which is a list of categories, traits, which is a list of distinguishing elements, and members, which is a list of examples. The genus and kinds orient the class into a taxonomy. The categories and traits distinguish this class from other classes. They are considered to be the intension of the class. The members or examples are the extension of the class. Concepts typically arise from reasoning and problem-solving activities. Concepts are often formed to represent inconsistencies or contradictions. As the inconsistencies are explained, the traits and classes are assimilated in a process called decentration. Therefore, it's typical for a concept to be constructed without traits or classes. Some concepts start out empty, and over time they are elaborated. Some of the circuits are derivative circuits. For example, hypotheses are derived from the tandem. A hypothesis has a premise, which is the antecedent or prior, and it has a surmise, which is the subsequent or later. Causal and logical hypotheses, called implications, are derived from hypothesis. Memberships are positive examples, refutations are negative examples. A sign is a symbolism where the signifier does not resemble the signified. A symbol is a symbolism where the signifier shares common features with the signified. Signs are communicated through language. Metaphors state that the signifier and signified can be directly substituted because of a similarity. Similes, or analogs, merely assert that two things have a similarity. Events are derived from an idea. An analogy is a list of substitutions. Entities are cross-modal assemblies that specialize unison. Situations are assemblies in the causal physical realm. Objectives are assemblies that are desired in the causal physical realm. Desiderata are assemblies in the logical realm. Statements are assemblies in the logical realm. Intentions indicate that a particular actor has a particular objective. An episode is a series of events. Lessons are problem solution pairs. Frames are based on George Lakoff's work and Mark Johnson's work on embodied cognition and on Roger Shank's work on scripts. A frame contains roles and scenarios are classes of episodes. Roles are categories. Actions are composites of other actions or actuations. And operations are composites of other operations or knowledge transmutations. Whereas a category is a list of elements, a problem is a list of initial elements and desired elements, often in the causal or physical realm. A lacuna is a gap in the logical realm, and a lacuna lists premises, which is a list of elements, and conclusions, which is another list of elements. A theme is a set of elements and with an origin that is either ascribed, empirical, or logical. A maxim is a theme and some advice and reason for that advice. A maxim is a higher level problem. Theories are leagues comprised of repeatedly activated co-occurring objectives, actions, operations, and hypotheses. And leagues are activated by the majority of their elements being activated. Obstacles and contradictions derive from concept. An obstacle is a concept in the physical or causal realm. A contradiction is a concept in the logical realm. Potentiation. Potentiation is creating new circuits based on recent activation. To potentiate means to enhance or to make something more effective or potent. Most accounts of potentiation focus on chemical changes in presynaptic and postsynaptic neurons in the brain. This focus is akin to describing how a spreadsheet program works by reporting on assembly language instructions. Scientists who've worked on potentiation have done a tremendous service to humanity by informing us what goes on in the brain. From a high-level perspective, potentiation focuses on creating associations across varying brain regions, often via Hebbian learning, firing together and wiring together. For the present purposes, potentiation means creating associative circuits or schemes using recent activation. The assembler forms assemblies. These are unimodal perceptual gates containing percepts, features, and image schemas. The unison relationship represents an AND gate, where all the elements of the gate must be activated concurrently. Grounding features. Activated features are associated with activated percepts by the grounder mechanism. The grounder mechanism forms grounding relationships between associated triggers and a percept. Image schemas connect unimodal features, that is, features that are in one modality. The imager mechanism creates image schemas. Short-term potentiation, forming entities. The interfire forms cross-modal gates. Forming tandems. The tandem associator, or tandy for short, creates tandem relationships. Forming series. The seriator mechanism forms serial relationships based on tandem relationships. Middle term potentiation. Forming vertical associations. The plexor forms grouping relationships, otherwise known as vertical associations. The plexor can identify when entities contain elements that are the same. Then they are grouped as similar. Forming categories. A categorizer mechanism creates categories. Forming attributes. An attributor mechanism creates attributes. Forming ideas. An ideator mechanism creates ideas by collecting attributes as elements of the idea. Grounding ideas. The grounding mechanism links ideas to percepts. During potentiation, activated features are associated with activated percepts, as well as activated ideas are connected to activated percepts. Acquiring language. Roland Hauser's speaker-hearer model of communication suggests that a speaker and a hearer communicate. The speaker has content types, and the speaker can generate surface tokens. These surface tokens are transmitted as signs to a hearer. The signs could be either in the visual modality, such as sign language, or in the speech modality, as speech, or in other modalities as well, perhaps Morse code. The hearer recognizes the signs, converts them to tokens, and then the tokens, the surface tokens, are converted back into content types. For the purposes of an artificial mind, we've adapted Roland Hauser's speaker-hearer model so that the speaker has inferences or coordinations, and those coordinations are transformed into observables. And those observables are transmitted as signs to a hearer, who also receives the observables and recognizes them and converts those observables into mental inferences. Language acquisition is about the hearer learning to recognize observables and creating the commensurate coordinations. Phonemes activated in tandem are linked. So phonemes are percepts in the phonetic modality. We can translate in some of these phonemes as these percepts as their underlying phonemes. So we have silence, we have k, a, e, t, and as phonemes. These phonemes are activated in tandem and they are linked. Choices are discovered for phonemes that have multiple transitions. These multiple transitions are known as allomorphs. Morphemic categories are formed for the phonemes and choices. The seriator sequences category activation. The series are equivalent to left associative morphemic transition rules or word rules. These are typically supported by long-range interneurons or LRIs. Constructing ideas using activation. The observer spreads activation while the activator activates individual observables or coordinations. The attributor groups categories and category elements into slots. And ideas are words. Here, we've constructed the word cat using activation. The process is reiterated at the next higher level tier to create phrases by crafting left associative phrasal transition rules. Ideas activated in tandem are linked. Here we substitute the actual morphemes or words for the ideas so that we can have a better view. So we see that John, Julia, is always working and dreaming are ideas that have been activated, that have been encountered, that have been constructed. The ideas are grounded to coincident percepts. The percepts are assembled into cross-modal entities by the entifier. The ideas activated in tandem are linked. And choices are discovered for morphemes that have multiple transitions. Categories are formed for the words and choices. And the seriator sequences category activation. And the series are equivalent to left associative phrasal transition rules, also supported by long-range interneurons. Constructing events using activation. The activator and observer work together to propagate or spread and activate the observables and coordinations. The attributor identifies activated categories and their elements as slots. And the event or phrase is constructed based on the activation of the slots. So here we see the event Julia is always working represented. Locating scenes. In the prior video entitled Genesis, we introduced a scene agent which created scenes. The locator agent adds scenes to the current venue and creates new venues and locales when the odometry indicates the robot has moved and the current scene no longer matches known scenes. The locator activates known venues and locales when known scenes are activated. The locator finds scenes in the venue and attaches the scene to the venue. Or if no venue exists, it will create a venue for the currently active scenes. Also, it will create a locale for the venue. As more scenes are encountered, as the robot moves around or looks around, the scenes are connected to an existing or a new venue. The mapper links venues to locales. As more scenes are introduced by the scene agent, the locator will correspondingly create venues or retrieve venues to match those scenes and create locales for those venues. The locator adds scenes to the current venue and creates new venues and locales when the odometry indicates the robot has moved and the current scenes no longer match known scenes. It activates known venues and locales when known scenes are activated. The mapper maps locations by creating, merging, or splitting mental maps of the environment using landmarks and scenes. When a map is created, it has one region, one area, one place, one locale, and one venue. The current scenes are added within the venue. The The mapper connects activated regions, areas, places, and locales during potentiation. There may be several background scenes of a particular venue or landmark. The venue represents the odometry of the robot within a particular trajectory and time threshold. A locale is an imagined or actual landmark. There are multiple venues per locale. A place is a grouping of locales. An area is a grouping of places. A region is a grouping of areas. And a map is a grouping of regions. During potentiation, the mapper wires together the activated locales within the activated places, areas, regions, and maps via Hebbian learning. And chunking. The mapper creates, merges, or splits mental maps of the environment using landmarks and scenes. When a map is created, it has one region, one area, one place, one locale, and one venue. The current scenes are added to the venue. The mapper connects activated maps, regions, areas, places, and locales during potentiation. Extended potentiation. Forming episodes. The tandem associator links events together, forming sequences of events. An episode is a sequence of events. Another example, we'll go into more detail on the event. We'll say one event is John has $40,000. Mary has a Tesla 3. Mary wants $40,000. John wants a Tesla 3. John gives Mary $40,000. Mary gives John a Tesla 3. John has the Tesla 3, and Mary has $40,000. All of these can be linked into an episode. A scenario is a generic episode. The prototyper creates scenarios, as well as prototypes. The prototype is formed by taking an event and collecting the categories for the slots of the event. These categories for the slots are called roles. The prototyper creates scenarios. Forming frames. The framer agent creates frames. Starting with a scenario, a frame schema is created, which contains the scenario. All the relations are gathered together from the scenario, and all of the categories are gathered together from the scenario. Frames are based on George Lakoff's work on embedded cognition and Roger Shank's work on scripts. A frame contains roles, relations, and scenarios. Scenarios are episode categories. Forming instances. The Simon mechanism makes simple relationships. Two ideas can be connected by a genus relationship, which creates a hierarchy between two ideas, one idea inheriting from another idea. In this way, small hierarchies can be created. The exemplar creates membership relations between ideas. And the members are instances of the taxonomic relationship. A class binds genus, members, and category. To create a class, we must first find a structure which is a member of a genus. And find that member's genus. If it also has a genus, then it can become a class, if it is not already a class. We find all the categories and the traits. For all of the slots of the idea. Then we find the genus of that initial class. Then we find the kinds. And lastly, we find the members. So to form a class, we find an idea, then the genus, the categories and traits, the kinds, the members. Learning from experience. And forming hypotheses. Empirical causal hypotheses that some situations follow others within a given time frame can be created. The Theon mechanism forms causal hypotheses. Logical hypotheses that certain ideas are enabled in tandem may also be created. Episodes can be instances of hypotheses when an episode has the same preconditions as the hypothesis. Forming theories. Theories are leagues of repeatedly co-occurring objectives, actions, operations, intentions, and hypotheses. Themes are high-level synopses among intentions and hypotheses. Themes are what Shank calls thematic organization packets. Themes can be useful for projection. They may be ascribed, which is conjectured based on cause-effect analysis. Empirical means directly inferred from observations. Or logical means inferred from reasoning. When a problem and a hypothesis of a theme contains the same preconditions as an episode, then an episode is an instance of the theme. Episodes can be instances of themes. Forming lessons. A lesson is a problem-solution pair. Lessons are based on Robert Walensky's work in story understanding on the PAM system. Walensky defined a story point as a problem-solution pair originating from the notion of a content story point. When various episodes are found to have common problems and solutions, lessons, or story points, may be inferred from them. The Toth mechanism identifies an activated problem for which there is no lesson. It looks for an enabled episode in all realities having terms related to the problem and which achieves the expected situation of the problem. Starting from the same preconditions and steps as the problem, the cause will be the situation formed from the differences between the preconditions and the steps. The solution will be the episode that solves the problem. Episodes can be instances of lessons. When a problem and solution of a lesson contain the same preconditions as an episode, then the episode is an instance of the lesson. The exemplar creates instances among episodes and lessons. forming maxims. Maxims are loosely based on Mike Dyer's work in thematic abstraction units. Maxims represent meta-lessons and can be useful for hypothetical projection. The theme is a recurring problem characterization. The reason is the underlying theory for the theme, and the advice is a theory that avoids or repairs the theme. Episodes can be instances of maxims. When the theme and the advice of a maxim contains the same elements as an episode, then the episode is an instance of the maxim. The exemplar mechanism creates instances among maxims and episodes. Evocation. Symbolisms. A symbolism is a relation between a signifier, which is presently active, and a signified, which is recalled or imagined. The signifier evokes the signified. A symbolism arises when an entity activated in the observer reality, this entity is called the signifier, repeatedly activates an entity in a recalled or imagined reality. That entity is called the signified, with some statistically significant frequency. Previously, these entities would be both activated in unison or in series in the observed reality, but over time an evocation arises so that the signifier in the observed reality evokes the signified in a different reality. Symbols are symbolisms bearing a resemblance between the signifier and signified. Resemblance can be taken to mean shared attributes or similarity. Signs are symbolisms bearing no resemblance between the signifier and signified. Metaphors. A metaphor is a symbolism among entities in two juxtaposed events. The metaphor-associative mechanism forms a new metaphor for events that are activated in tandem across observed, imagined, and recalled realities. Episodes can be instances of metaphors. Since a metaphor is a direct comparison between a signifier and a signified, in technical usage the word metaphor may often be a metonym for the word analogy. When it is said that something is a metaphor, it is often implied that an analogy, that is, a set of analogs or similes, exists. A metonym substitutes a part of a thing for the entire thing. For example, Bigfoot is a metonym that labels the entire entity by its footprint. Mechanisms. Associators. There are many associators. They all have specialized functions. The assembler creates unimodal unison gates. The attributor creates slots. The categorizer creates categories. The chooser creates choice gates using tandems. The classifier creates classes. The conceiver creates concepts. The decentrator adds traits and classes to concepts. The identifier creates cross-modal entity gates. The eventer creates events. The exemplar creates members. The framer creates frames. George creates symbolisms, metaphors, and analogies. The ideator creates ideas. The locator connects scenes to venues and venues to locales. The mapper merges locales, places, areas, regions, and maps. The prototyper creates prototypes. The plexer creates vertical relationships. The seriator transforms tandem relationships into series. Simon creates simple relationships. Tandy creates tandem relationships. Dion creates hypotheses and theories. Toth creates lessons, themes, and maxims. Chunking. Category formation is the process by which a person forms mental categories from their experiences. Category chunking is the act of combining elementary memory units into composite memory units. The chunker agents in this chapter perform unsupervised category induction through an incremental hippocampal chunking algorithm called the cruncher. Mark Pickett and Tim Oates in 2005. The cruncher generates hierarchical ontologies from groups of feature sets using minimum description length principle. The algorithm works incrementally by comparing new memory units added to an existing ontology. Any two memory units having the same features are arranged in a vertical relationship, and their common features are eliminated from the newer unit. Crunching. In a second phase, any two units with common features are arranged under a new parent memory unit, to which the common features are transferred. Combining. The chunkers described herein are non-destructive. Unused memory units will simply be garbage collected over time. Ontology. A category is represented below as a reifier and a set of elements of the category. For example, a reifier of 55 and elements 1, 2, 3, 4. The reifier serves as the ID of the scheme. Using this schematization, no pun intended, given a random ontology with various categories or reifiers and various category elements, We can chunk the categories to create a hierarchy. Crunching. We create genus relationships where we have a subset 103 and a superset 108. We can eliminate the redundant items from the superset. 106 and 111. 111 is the subset and 106 is the superset. We can eliminate the redundant items from the superset. Likewise with 112 and 105, both of which have the same elements. So we will eliminate all the elements from one of the schemes. So now we can compare the original to the crunched version. Combining. The combining phase looks through pairwise all of the elements and looking for intersections. New categories are formed for the intersections, and hierarchies are created. Then redundant elements are removed from the leaves. The process continues until all elements in the hierarchy are compared. The original, the crunched, and the combined or chunked. Mechanisms. The mechanisms perform chunking over various aspects of the hierarchy. Categories, classes, concepts, features, ideas, metaphors, unisons. O deep thought computer, the task we have designed for you to perform is this. We want you to tell us the answer. The answer, said Deep Thought. The answer to what? Life, the universe, and everything. Can you do it? Yes, said Deep Thought. There is an answer, but I'll have to think about it. 7.5 million years later. The answer to the great question of life, the universe, and everything is 42, said Deep Thought, with infinite majesty and calm. Douglas Adams. Solving. Solving is the process of retrieving or creating complex actions that bridge spatiotemporal gaps, called problems, between initial situations and desired situations, or that overcome causal contradictions, also known as obstacles, surprises, or failures. Solving occurs in the causal realm. The method is planning. Elements are observables or events. Collections of these elements are situations. Primitives used in planning are actuations. Composites of these actuations are actions, and groupings of these actions are skills. Gaps are problems, and inconsistencies encountered are obstacles. Insufficiencies in planning are called objectives. Planning is the process of creating sequences of actions or actuations. Specialized problem solvers propose viable action or actuation paths from situations to objectives. If there are no relevant existing paths, a problem solver will propose a path in the form of a complex action. Observables received by a perceiver are forwarded as situations to an action selector and concurrently to problem solvers. Events are idea structures that represent conditions in the world. Situations are assembly gates containing observables, events, or both. Episodes are league gates containing events or other gates. Actuations are primitive motor behaviors that a device can perform. Actions marshal an ensemble of actuations to execute a complex behavior. Actions are physical and exert forces upon objects. Actions may be cross-modal. Skills are collections of actions. Problems are spatio-temporal gaps between initial situations and desired situations. Obstacles are causal contradictions that expose differences between expected and unforeseen situations. Objectives are conditions or events that are desired and are expected to resolve a deficiency, fill a gap, or correct a situation once achieved. Here's what it looks like when it's mapped out in a conceptual graph. So we ask, what is the game? Given a totality with distinctions, we have an activated situation comprised of observables or events or some combination thereof, currently activated in the observable empirical reality. And we have desired objectives, whether an observable or event or some combination thereof, which is not currently activated in the observable empirical reality. The gap between the situation and the objectives is called a problem. And the game is to find some action or group of actions that will activate the objective or objectives in the observable empirical reality. During the game, in the process of searching for the proper actions, we may encounter causal contradictions or failed predictions we call obstacles. The actions must accommodate the obstacle to achieve the objectives. That's the game, selecting or creating the proper actions to achieve the objectives. Mechanisms. There are many problem-solving mechanisms. We have different kinds of solvers: analogical, associative, hierarchical, means-ends, plan space, state space, graph, lesson-based, episodic, genetic. Analogical planning is the process of creating actions by searching for and adapting analogous actions. This mechanism proposes an action for a desired objective based on similarities between the situation and the results of another action. It finds an overarching analogical relationship that matches another action, then duplicates the action, substituting all the analogs in the preconditions and postconditions. Associative or case-based planning is the process of retrieving or creating actions based on the degree of match between the problem and action situations and objections. This mechanism creates a new action by duplicating the best matching candidate action and adapting the candidate's situation and results to match the current situation and objectives. In hierarchical task network planning, actions are decomposed into primitive actuations in order to create a fully instantiated composite action having only actuations. This mechanism uses actions and actuations as primitive operators in order to compose a new hierarchical action. Means-ends analysis is the process of repeatedly selecting and applying actions that reduce the difference between the current situation and desired situation. This mechanism creates a new action through means-ends analysis. Finally, a naive cost measure is employed, which prefers shorter difference sets between the objectives and the current situation. Some planning problems cannot be solved by pursuing goals individually. A famous example of this is the Sussman anomaly, wherein two objectives are pursued individually, and the resulting subplan for the second objective invariably undoes the attainment of the first objective. Plan space planning allows the pursuit of such non-serializable objectives. This mechanism uses plan space planning to propose an action for an objective. A state space solver looks for actions to transform an initial situation into a desired situation. This mechanism creates a new action using backward chaining search by selecting a sequence of relevant actions that transform the initial situation into the desired situation. There are many kinds of state space solvers, including Monte Carlo solvers, depth first, breadth first, best first, and so forth. Many different kinds of state space search algorithms can be employed. The graph plan solver mechanism proposes an action by iteratively extending and searching a planning graph. A planning graph is a data structure that shows transitions in time from an initial situation to applicable actions to linking schemes to applicable actions, and so forth. Starting from the initial situation, on each time step, new transition actions and their results are introduced. Eventually, the hope is that the actions will transition to the objectives. On each time step, mutually exclusive actions and mutually exclusive schemes are identified so as to constrain the order of actions in the final action. Once mutually compatible, non-exclusive objectives occur in the planning graph, an action can be extracted by backward chaining the actions from the objectives to the initial situation. Since schemes set increase monotonically, if similar schemes are encountered in each time step and not all objectives have appeared, then the graph may have reached a stasis point in which the objectives may not be achievable. This approach trades off space for search time and has in cases been proven to be much faster than plan space or state space approaches. Lessons are problem solution pairs which can provide analogical transfer of experience. The objective of a lesson may be related to the current objective. This mechanism proposes solutions to problems by finding a similar lesson. The current objective and problem objective are generalized to find commonality. When the current objective matches the results of an activated episode, then we can propose an action similar to the episode. The episodic solver mechanism proposes an action based on an existing activated episode. The genetic solver mechanism employs a genetic algorithm to propose an action. The genetic algorithm evolves an action by mutating and recombining an initial population of candidate actions until an action is found that meets a fitness threshold within a specified number of generations. Reacting. Reaction is the ability to respond reflexively to one's environment. The reaction pattern is a loop wherein reliable actions are triggered by observables. This pattern is useful when immediate responses to observables are needed. Deliberating. Deliberation is selecting actions that achieve goals. Specialized problem solvers find viable event paths from situations to objectives. If there are no relevant existing paths, a problem solver will propose one in the form of a complex action. Observables received by the perceiver are forwarded as situations to an action selector called the deliberator, and concurrently to problem solvers. The deliberator retrieves actions applicable to the current situation and relevant to the current objectives. This pattern is useful when a system is required to achieve or maintain objectives. Reasoning is what enables the human mind to go beyond mere perception, habit, and instinct. Mercier and Sperber. Reasoning. Reasoning is the process of retrieving or creating operations that use knowledge transmutations to both bridge logical gaps, called lacunas, between initial premises and desired conclusions, to resolve contradictions, explain phenomena, justify conclusions, and persuade oneself or others. Reasoning occurs in the logical realm. The method is inference. The elements are propositions. Collections of propositions are statements. Primitives used in reasoning are transmutations. Composites of transmutations are operations, and groupings of operations are knowledge. Gaps are lacunas, inconsistencies are contradictions, and insufficiencies are desiderata. Inference is the process of deriving new knowledge from existing knowledge. The inferential theory of learning by Mikulski posits that learning is a goal-directed search through a knowledge space using transmutations as search operators to derive desired knowledge given premises, possibly received by the senses, and background knowledge. In other words, learning modifies the learner's knowledge by exploring the learner's experience in a goal-directed manner. Behavior improvement, therefore, occurs because of changes in the logical content, task-related organization, or subjective certainty of the learner's knowledge and skills. Planning with actions, simple and complex device actuations, in the causal space is akin to planning with operations, knowledge transmutations, in the logical space. In the causal realm, problem solvers use actions to find pathways among situations to achieve objectives. In the logical realm, reasoners create and use operations to bridge gaps in understanding and form logical inferences. Lacuna are gaps in understanding that arise from logical contradictions or failed reasoning. Lacuna can be bridged by operations. Operations are created by reasoners that specialize knowledge transmutations to fit a particular context. Together, operations and theories form a non-monotonic meta-model of reality, which is used to choose objectives that attain preferable situations and avoid undesirable situations. The reasoning process helps to ensure this mental model is coherent and consistent. When the reasoning process is successful, desiderata are replaced by logical hypotheses, which summarize chains of inference among theories, operations, and desiderata, and affect situations in the causal realm. The results of any reasoning endeavor are assimilated into the learner's background knowledge for future use, forming a closed-loop system. A learner must therefore be able to perform inference and memorize, hence Mikulski's equation, learning equals inference plus memory. The background knowledge typically exists in the totality as unary or binary schemes of the form relation argument or relation argument equals referent. Propositions are typically idea and event structures that represent conditions in the world. Statements are assembly gates containing ideas and events. Theories are Lie gates containing statements, operations, actions, and hypotheses. Transmutations are primitive knowledge manipulation functions that can be applied to premises, collections of propositions, and known background knowledge to produce new inferences. For example, the deductive referent generalization transmutation says that for each premise in the list of premises, let the referent symbol be randomly picked from the reference of the premise, and match a genus relation where the reifier of the genus is in the known background knowledge, and the mesa slot of the genus equals the referent, and the meta slot binds to the symbol meta, creating a list of each match, by copying a new scheme using the premise as the reifier and substituting the referent for the meta value. There are a plethora of knowledge transmutations identified by Richard Mikulski, Jean Piaget, and others, which can be implemented according to different strategies. Operations combine transmutations and other operations to create inferences. An operation posits that if the premises are activated and the assumed background knowledge exists, then results can be obtained and activated by performing the sequence of sub-operations. The premises and known background knowledge produce the results. Operations are composable and support reversibility. Knowledge is herein defined as collections of operations. Lacunas are gaps in argumentation between initial premises and desired conclusions. Contradictions are logical inconsistencies that expose overlaps between complementary categories. Desiderata are essential propositions that are not yet proven. Here's what it looks like when it's mapped out in a conceptual graph. So the question is, what is the game this time? Given an activated assembly of premises comprised of observables and coordinations, which are currently activated in the possible reality, and desired conclusions called desiderata, whether an observable, coordination, or some combination thereof, which is not currently activated in the observable empirical reality, the gap between the premises and the desiderata is called the lacuna. Find some operation or group of operations that will bridge the gap and activate the desiderata in a possible reality. During the process of searching for the proper operations, we may encounter logical contradictions or overlaps in complementary categories. The operations must introduce negations to successfully obtain the desiderata. That's the new game. Selecting or creating the proper operations to obtain and activate the desiderata. Strategies. Preconcepts differ from concepts in that they lack identity through time. Preconcepts fail to properly demarcate individuals, often mistaking one individual as several or several individuals as one. For example, a child may identify two different worms as the same worm, or think the same dog is two different dogs when seen at two different points in time. Preconcepts also lack the notion of class. During this phase, everything is treated as particulars or individual items, rather than being generalized under a class. This practice is extended to meronomic or part-whole relations as well. The child often sees distinct parts rather than the wholes into which they compose. When a child is able to reason symbolically and preconceptually, she can use sensory motor actions, images, and words to conceive goals and means and employ symbolism or imagination to distort reality while problem solving. The distortions most often occur during reasoning, which at this point is largely transductive, from particulars to particulars, and therefore will typically lead to unnecessary inference contradictions if incorrect. Preconceptual thought leads to artificialism, animism, intuition, and later operational thought. Artificialism is the belief that everything has a creator, which may be any entity, whether an object or a person. Children acquire this notion during the egocentric period. For example, children may believe that the sky makes the sun, or that grandmothers make themselves, and so forth. Artificialism ranges from diffused or unsystematic to mythical, utilizing preconceptual narratives, to immanent, attributable to nature. Animism is the belief that everything is alive, especially inanimate things. Animism results in a number of transductive reasoning errors. Since the child is unaware of the subjectivity of her thought, her intentions, her effort, these internal elements are attributed to any external situation capable of corresponding to her movements and her activity by an analogy which is immediate and not conceptual. For example, a child might make reference to a moon hiding in the clouds, or she might say the clouds move by themselves because they are alive, or that a car knows which way to drive. Magic phenomenism is the confusion of correlation and causality, as well as the erroneous ascription of causes. For example, a child might think that clouds move because trees move or trees make wind. This begins in the sensory motor period and continues throughout the egocentric period. As the child's thoughts become socialized, the child gains the ability to not only dissociate her own viewpoint from that of others, but also gains the ability to coordinate multiple viewpoints, thereby abandoning subjective beliefs in preference to objective beliefs. Intuitive inference. Intuition is the linking of preconcepts to operations. Intuition is semi-reversible, eventually leading to reversible subsystems. Transductive inference is reasoning from particulars to particulars using preconcepts, ideas, events, or anything that's not a concept. It differs from analogical reasoning only in that analogical reasoning employs concepts. Infralogical inference. Infralogical inference is reasoning which establishes that objects encountered at different moments in time, however different in appearance, for example, despite changes in perspective, are the same. Infralogical reasoning establishes that the picture hanging on the wall 5 seconds ago is still the same picture you are viewing now. Errors in infralogical reasoning may lead you to believe the cat you spotted on your morning walk 5 minutes ago is the same cat you are now encountering. Egocentric phased children often make these errors. Piagetian inference. Inhelder and Piaget identified 4 kinds of reasoning: sensory motor, intuitive, concrete, and formal. Sensory motor reasoning pertains to the coordination of actions. Intuitive reasoning explores characteristics of actual situations. Concrete reasoning employs operations upon objects to create and manipulate transformations between empirical situations. Formal reasoning employs operations upon propositions to derive knowledge from hypothetical situations. Conceptual inference occurs during a person's operational developmental period. According to Mikulski, background knowledge typically exists in the form of conceptual categories arranged in fairly static type or part hierarchies. These categories are used to form unary or binary propositions, which are manipulated via deductive, inductive, and analogical inference. Deductive inference. Deduction, deriving conclusions given premises and background knowledge, creates both strong and weak conclusions. Deduction is truth preserving, so true premises and true background knowledge will create strong conclusions. Deductive inference is of the form: given P premises and background knowledge BK, derive conclusions C. Inductive inference. Induction, hypothesizing premises given conclusions and background knowledge, creates both strong and weak premises. Induction is falsity preserving, so false conclusions and false background knowledge will create strong premises. Given conclusions C and background knowledge BK, hypothesize premises P. Analogical inference. Analogy uses premises and background knowledge to hypothesize a similarity between two categories with respect to certain properties. Extend the similarity to other properties, and then derive new properties for the second category. Analogy creates weak conclusions. Analogical inference is of the form, given premises P and background knowledges Bk, hypothesize similarities S, and derive conclusions C. Alternative inference. Other forms of inference have been lumped together as alternate strategies. Transmutations. Transmutations are the primitive knowledge manipulation functions that can be performed. There are a finite number of possible transmutations that can be undertaken. The process of reasoning therefore involves applying a knowledge transmutation to premises, background knowledge, or conclusions in order to derive new propositions, called inference. Generalization and specialization are transmutations that can be done in a deductive, analogical, or inductive manner. The purpose of generalization or specialization is to substitute a generalized or specialized value for one in an existing premise proposition. Given a premise and a known genus hierarchy, a result conclusion may be achieved by substituting the more general or special element of the background hierarchy. For example, if we say Chucky has a pit bull, and the pit bull's genus is dog, we may conclude that Chucky has a dog. This is generalization. Likewise, if we say Sharon has a dog, and the terrier's genus is dog, we may conclude that Sharon has a terrier. This is specialization. Abstraction and concretion can be performed in deductive, analogical, or inductive manners. The purpose of abstraction or concretion is to reduce or increase the propositional information. Abstraction removes elements of a situation while concretion adds elements to the situation. For arguments or reference participating in an abstraction hierarchy, abstraction or concretion substitutes a higher or lower element in the hierarchy with the argument or referent. If we say the quick fox, abstraction will allow us to say the fox, thereby decreasing the amount of information. If we have the lantern, concretion will allow us to say the green lantern, thereby increasing the amount of information. Similization and dissimilization can be done in a deductive, analogical, inductive, or transductive manner. The purpose of similization or dissimilization is to construct a new proposition, argument, or referent based on similarity or dissimilarity with an existing one. We say the cat has feet, and we know the cat has a similar motion to fog. We can conclude by similization that the fog has feet. If we say wood floats, and we know that wood has a different density than stone, we may conclude by dissimilization that stone does not float. Agglomeration and decomposition can be done in an infralogical or alternate manner. Agglomeration and decomposition. Agglomeration creates new categories by clustering existing categories into a larger grouping. Decomposition creates new categories by dividing existing categories into smaller groupings. We have a category of wallet, money, and keys, and another category of notebook. We can have a resulting category of wallet, money, keys, and notebook. That is agglomeration. On the other hand, if we have a category of wallet, money, keys, and notebook, via decomposition, we can get two categories, one category of notebook and another category of wallet, money, and keys. The prediction, explanation transmutations can be done in a deductive, analogical, inductive, or transductive manner. Prediction hypothesizes a consequent which the premise implies. Explanation, also called abduction, hypothesizes an antecedent that implies the premise. Given premises cloudy weather and known cloudy weather causes rainy weather, We can conclude rainy weather by prediction. Conversely, if we have the premise rainy weather and known background knowledge cloudy weather causes rainy weather, we can conclude maybe cloudy weather. Selection and generation can be done in a deductive, analogical, or inductive manner. Selection eliminates candidate elements from consideration. Generation creates candidate elements for consideration. If we have premises bat, ball, glove, and cap, by selection, we have the result glove. Likewise, if we have no premises, by generation, we have tomato, celery, lemon, and lettuce as candidate results. Characterization and discrimination can be done in an infralogical or alternative manner. Characterization creates a new category for a set of elements, often by simply conjoining element traits. Discrimination creates a category that distinguishes one set of elements from another set of elements by finding traits common to one set and disjoint to the other set. So if we have premises, glasses, sandwich, apple, keys, and known background knowledge, sandwich is similar to apple. By characterization, we can derive a category, glasses, sandwich, keys, apple. If we have premises, glasses, sandwich, apple, keys, and we have sandwich similar to apple, by discrimination, we can have three sets, glasses, sandwich, and apple in a category, and keys. Association and dissociation can be done in deductive, analogical, inductive, or transductive manners. Association creates a causal, statistical, temporal, or other dependency between two or more categories based on background knowledge and empirical observations. Dissociation asserts a lack of dependency. For example, determining a given instance is not an example of some concept. We have premises, two events. We can say one event causes the other. This is association. If we have an idea and a class, an idea is an instance of a class, by dissociation, we can say that idea is refuted or is a counterexample of the class. Modus ponens and modus tollens are done in a deductive manner. Modus ponens, from the Latin mood that affirms, modus ponens states that if a hypothesis is accepted and the antecedent of the hypothesis is true, then the consequent can be inferred. The transmutation states if the antecedent of a hypothesis is enabled and either the certainty of the hypothesis is above a predefined threshold or the hypothesis is logical, then the consequent can be enabled. Here we have an activated premise A and a known implication or hypothesis, A implies B. Therefore, we have an activated result, B. This is modus ponens. From the Latin mood that denies, modus tollens states that if a hypothesis is accepted and the consequent of the hypothesis is false, then the negation of the antecedent can be inferred. The modus tollens transmutation states that if the consequent of a hypothesis has an enabled dyad, that is the negation of the consequent, and either the certainty of the hypothesis is above a predefined threshold or the hypothesis is logical, then the dyad of the consequent can be enabled. So if the scheme not B is active and there's a known hypothesis, A implies B, we can activate the scheme not A. Reformulation and randomization is an alternative transmutation. Reformulation transforms a set of propositions into a logically equivalent set of propositions. Randomization mutates a set of propositions into another set of propositions by making random changes. The crossover genetic algorithm is an example of randomization, since it derives new knowledge by exchanging two segments of related knowledge components. Given premises 3 blind mice as a series, and known equivalences 3, 3, and 3, by reformulation, we can get 3 blind mice. Given premises a series called a motley crew, and known elements, 6 red hens, 4 calling birds, 5 golden rings. By randomization, we can get 6 motley rings. Insertion and deletion are alternative transmutations. Insertion modifies existing knowledge by inserting a knowledge component into a knowledge structure. Deletion modifies existing knowledge by removing a knowledge component from a knowledge structure. So if we have a series, motley calling, and known background schemes, 6 red hens, 4 calling birds, 5 golden rings, we can get a resultant scheme by insertion, red motley calling. If we have a series, 3 little birds, by deletion, we can have another series, a resultant series, 3 birds. Replication and destruction are done by alternative means. Replication copies knowledge structure from external sources. Destruction removes a knowledge structure from the knowledge base. Destruction differs from deletion in that deletion removes a component of a knowledge structure rather than the entire structure. Sorting and unsorting are done alternatively. Sorting or seriation organizes knowledge by creating an ordering according to some criterion. Unsorting removes an ordering of knowledge, returning it to a pre-sorted state. So if we have a series, lemon, banana, and we have an ordering known, pear, banana, mango, apple, lemon, we can use the ordering to sort our premises so that we have a series, banana, lemon. If we have a series, banana, lemon, and we have a known series, lemon, banana, we can have 2 series of lemon, banana. We can return our sorted series to its unsorted state. The differentiation and integration transmutations can be done via alternative strategies. Differentiation replicates a knowledge structure and introduces unique components into the copy to distinguish it from the original. Integration fuses distinct knowledge structures by sharing a subset of the components from each structure. So if we have premises, the fox, we can have a result series, the fox and the quick brown fox. The fox has been differentiated into the quick brown fox. If we have 2 series, what dreams and may come, we can integrate them to have 3 series, what dreams, dreams may, and may come, where the integrated series shares elements of the 2 original series. This is integration. Complete affirmation and negation are transmutations that use the Potentiation strategy. Complete affirmation is the application of the recursive logical multiplication operator to create a set of propositions such that P multiplied by Q is P and Q, P and not Q, not P and Q, not P and not Q. This was often used on intelligence tests by Piaget to determine how well a child could or a student could generate possible derivations of a statement. Negation or inverse is the complement of an operation with respect to complete affirmation. Disjunction is the inverse of conjoint negation. So given prince and queen as premises, complete affirmation would give us prince and queen, prince and not queen, not prince and queen, not prince and not queen. If our premise was sunny, negation would give us not sunny. Conjunction and incompatibility are Piagetian transmutations. Simple conjunction. Incompatibility is the inverse of conjunction. Given premises apple and orange, conjunction gives us a unison of apple and orange, since the unison requires all elements of the unison to be concurrently activated. Given premises apple and orange, incompatibility will give us an incompatible apple and orange. Disjunction and conjunctive negation are Piagetian transmutations. Simple disjunction and conjunctive negation is the inverse of disjunction. Given premises dog and cat, we can get a category dog and cat. Either dog or cat may activate the category. Given premises rock and paper, conjunctive negation gives us the unison of not rock and not paper. Implication and non-implication are Piaget and transmutations. We have simple implication and non-implication. Given clouds and rain, by implication, clouds implies rain. Given sunny and warm, by non-implication, sunny does not imply warm. Reciprocal implication and negative reciprocal implication are Piagetian transmutations. The reciprocal of an operation is the same operation with the signs reversed. Negative reciprocal implication is negating the reciprocal of the implication. Given rich and happy as premises, using reciprocal implication, we will derive not rich implies not happy. For premises sunny and warm, negative reciprocal implication would imply not sunny does not imply not warm. Equivalence and reciprocal exclusion are Piagetian transmutations. Equivalence and reciprocal exclusion. Given premises struggle and progress, struggle is equivalent to progress by reciprocal implication. Given premises cake and satiety, cake or satiety is a choice. You cannot have both via reciprocal exclusion. You can't have your cake and eat it too, basically. Affirming P and negating P are Piagetian transmutations. Affirming P, negating P. If you have known background knowledge that P implies Q, you can activate P to affirm P. Given known background knowledge P implies Q, you can activate not P to negate P. Affirming Q and negating Q are Piagetian transmutations. Affirming Q and negating Q. Given known background knowledge P implies Q, you can activate Q to affirm Q. Given known background knowledge P implies Q, you can activate not Q to negate Q. Reasoning contradictions. A contradiction is a partial adaptation that manifests as a prediction failure. Contradictions usually arise when actions and operations are only partially correct. They motivate an individual to search for improved coherent knowledge. Contradictions are largely present at the beginning of development because negations are unknown. Recall that in the beginning of life, only affirmations are acquired from observables. Negations are created secondarily. Contradictions facilitate the creation of negations by triggering a process called equilibration, which constructs negations. Negations are needed for the creation of reversible operations. There are two categories of contradiction: physical, also called causal, and logical. For each of these categories, there are three subcategories: defective identity, incomplete compensation, and unnecessary inference. Defective identity causal contradictions indicate that some object or action has changed. For example, when you start your car in the morning, one day when you go to start your car, it doesn't work. Therefore, something has changed. A logical defective identity is a changed item or operation. Incomplete compensation is a failure to revert an action. Logical incomplete compensation is an overlap between two complementary categories. Unnecessary inference results in causal planning failures and results in logical reasoning errors. Defective identity. Causal defective identity contradictions occur when an individual performs the same action on an object in the same manner and gets different results with each performance. This implies that either the object or the action has changed between performances. Typically, when this happens, there has been some kind of change in the object between the performances rather than a change in the action. For example, when you start your car and it works, then sometime later you start the car and it fails to start. We can say that the car must not be identical to the one that started earlier. There is something different about it because the earlier car started, whereas now it fails to start. Something has changed. Incomplete compensation. Logical incomplete compensation occurs when the individual maintains a non-empty overlap in two complementary mental categories, for example, X and non-X. That is, when the individual simultaneously claims both that something is and is not a particular thing. For example, when an individual claims an animal is and is not an elephant. The elements common to the complementary categories are the contradictions. Physical incomplete compensation occurs when an inverse action is left incompletely neutralized or incompletely canceled. For example, when the person takes an action A, then attempts an inverse action A -1, which should cancel the first action, and is surprised when it doesn't. Since Piaget views negation as reversibility, the incomplete compensation is a failure in reversing an action. Usually the incomplete compensation is because of a failed prediction about the action itself or about an object used in the action. Causal unnecessary inference contradictions may arise from failures in planning when combinations of actions do not lead to a predicted result. Logical unnecessary inference contradictions most often arise in preconceptual transductive reasoning. Transductive reasoning infers particulars from particulars in contrast to deductive reasoning, which infers particulars from generalizations, or inductive reasoning, which infers generalizations from particulars. Transduction differs from analogy, which also involves reasoning from particulars to particulars, in that transduction uses preconcepts or ideas and events, whereas analogy uses fully formed concepts. When transductive inference occurs among simple objects, it's likely to be correct. When transductive reasoning occurs among complex objects, nested conceptual classes and class members, composite relations, or irreversible operations, then transductive reasoning is likely to fail. Centration. Centration occurs when an individual focuses only on specific, centered features of a situation and ignores other important features. This may occur because the centered features may be the only available features. The ignored features may not exist in the individual. The centered features may be the most activated features at the time. The centered features may be erroneously activated. An individual that is centered in a particular situation either lacks sufficient coordinations, lacks sufficient activation, or has incorrect coordinations which prohibit the consideration of the ignored features of the situation. An individual is decentered when she attains additional inferences, strengthens connections, or corrects inferences so that her problem solving includes the previously ignored features. So concepts are able to be elaborated in the process of centration so that new features, new traits, new categories can be added to the concepts. This is different from ideas or other structures. Centration is possibly caused by reasoning with incompatible particulars, where salient features of one particular are ignored while interesting features of another particular are scrutinized, so that the inferred conclusions are likely to be distorted. Centration becomes a source of contradictions and is likely one cause of unnecessary inference contradictions. When gaps are compensated, centered features of the gap may be overemphasized, while ignored features are de-emphasized. The ignored features can create disturbances, which may need to be compensated at a later time, possibly through a reorganizing equivalence. Thinking. Cogito ergo sum. René Descartes. There are several kinds of thinking. Experiments determine whether a hypothesis is valid. Recall activates an episode and its associations. Reasoning finds or creates operations for a lacuna. Solving finds or creates actions for a problem. Projection projects the present circumstances into the future. Explanation steps backwards from present to past to find the cause of an event. Backcasting steps backwards from the future to the present to find how to achieve a desired future state. It's also called backchaining. Hindcasting tests if a model is valid by running a forecast after an event has happened to see whether the model predicts the event. Prefactuation speculates on the possible future outcomes. Semifactuation speculates whether things would remain the same. Supposing X happened instead of E, would Y occur? Counterfactuation speculates on possible outcomes of different past. Suppose A happened instead of B. Reasoning mechanisms. There are a host of mechanisms to perform the desired modes of thinking. We have a backcaster, experimenter, explainer, hindcaster, prefactor, projector, prover, reasoners, recaller, refuter, semifactor, and supposer. A scientist would rather use another scientist's toothbrush than use their terminology. Anonymous. Terminology. The main problem with terminology is bridging language between philosophers who delve in logic, psychologists who study the mind, computer scientists who study algorithms. Hopefully we can rationalize the jargon and come up with something useful among them. The realms that we consider are the causal and logical. Methods are planning and inference. The elements are observables and propositions. Collections are situations and statements. The primitives that we use for planning and inference are actuations and transmutations. The composites are actions and operations. The groupings are skills and knowledge. The gaps are problems and lacunas. Inconsistencies are obstacles and contradictions. And insufficiencies are objectives and desiderata. Here's what it looks like when it's mapped out in a conceptual graph or topic map. We have logical and causal areas. What we need is some common terms that can bridge the gap between the logical and causal realms. By harmonizing the language, the problem of coordination can be simplified. And thereby simplify our overall effort. This allows us to go forward and design systems that can be seamlessly do both causal planning and logical reasoning, since actuations and transmutations can be interleaved. So now, in a rationalized terminology, for both the causal and logical realms, the method is essentially planning. The elements are events and propositions. The collections are called contexts. The primitives are actuations and transmutations. The composites are plans. The groupings are now called competences. The gaps are just called gaps instead of problems or lacunas. The inconsistencies are called errors. The insufficiencies are called goals. So from a unison, we get a context. Plans combine actions and operations. They have context and results, which are both assemblies of observables and coordinations. They also have steps, which is an assembly of plans, actuations, transmutations, or some combination thereof. Gaps present a logical or causal spatio-temporal distance between an initial context and the desired goals. Errors are contradictions that expose differences between expected and unforeseen situations or between mutually exclusive logical categories. Goals are desirable propositions that are expected to resolve a deficiency, fill a gap, or correct a situation. Competences are collections of plans. And the question now is, what is the new game? Given an activated context comprised of observables or coordinations or some combination thereof, which is currently activated in the possible or observed reality, and desired goals not currently activated in the same reality, the logical or causal distance between the context and the goals is a gap. The game is to find some plan or group of plans that will activate the goal or goals in that reality. During the process of searching for the proper plans, we may encounter errors. The plans must accommodate the error to obtain the goals by introducing negations. And that's the final game, selecting or creating the proper plans to obtain the goals. So we end where we started, with a generic cognitive architecture that has areas for memory, observation, coordination, reflection, and consolidation. with a specific cognitive architecture that has the same. The book Coding Artificial Minds will delve into the minutiae of building cognitive systems. The book Building Minds with Patterns is available on Amazon. If you found this information useful, please like the video and subscribe to the channel, and visit us on Patreon. Become a member so that we can bring you more helpful content. Find us on the web at Linktree. If you need advice on systems you are building, book a consultation on Calendly, or send us an email directly. We'll see you in the next video. I have seen everything that is done under the sun, and behold, all is vanity and a striving after wind. Ecclesiastes 1:14.